what will my t be? Pi over 2. Does pi over 2 live in here? Does pi over 2 live in there? Yeah, it might help you to go up here, just above this, and just kind of look at where you're looking at. Pi over 4 is here, isn't it? 7 pi over 4 is here. And so the region you're looking in is in this region, right? Any angle that lives in there is going to work. Do y'all get that? Wouldn't it have to be negative? What have to be negative?
If you're looking in the fourth quadrant,
well, there's two ways to get to the fourth quadrant, right? You can get there by going all the way around and coming back through. That's a positive angle. Or you could go backwards, which is a negative angle. But we're only looking in positives here. So does pi over 2 live there? Yes. Pi over 2 is straight up. So that's good. That's a critical number, pi over 2. Let's let k equal 1. So there's two ways you could do this. You could actually replace k with 1 and get pi over 2 plus pi, right? And to add those together, you'd have to get a common denominator. And that would be 3 pi over 2. That's one way you could do it. Or you could have said, hey, where was I? I was at pi over 2, right? Where was I? I was at pi over 2, right? And I added what? 1 pi. So pi is a half rotation. I'm down here now. That's 3 pi over 2. That lives in there? Okay, so that works. Should I continue with k being 2? No, I should probably stop here because you can tell. If we're down here now, right, at 3 pi over 2, and I add another pi to it, where am I going to be? Back up there. And now I've exceeded what I'm allowed to be in, right? I'm past this interval. So there are two critical numbers, pi over 2 and 3 pi over 2. Your calculator. This is why I was saying avoid the inverse function on your calculator. If you tried doing this on your calculator and you were trying to get an arc sine at some point, it's only going to give you one answer. You're only going to get one. So you'll be missing an entire critical number. So don't use your calculators to solve trig functions. To solve trig equations. I apologize. All right. What's next? Almost. Just almost erased it. There's one more thing I have to look at before I can go critical numbers in. Is this ever happen? Is the derivative ever undefined? Crap, look. There's a derivative, right? Is that ever undefined? Well, cosecant might be, right? Because it's 1 over sine. So let me consider this again. 1 minus 1 over 2 sine squared of 1/2 t. Is this the same thing? Yes. Yes, that's the same thing? So the only thing that's going to screw this up is if sine squared of 1/2 t is 0. Right? I'll get division by 0. But that would mean that sine of 1/2 t would have to be 0. Didn't we look at that earlier? Yeah. We did that when we were looking at the original function. Cotangent was cosine over sine. And we looked to see where sine of 1/2 t was 0. And we said it happened at these different places, but it wasn't in here, right? It didn't happen in here. So even though this is a problem, we don't need to consider it because we already looked at it. So this right here is not an issue. This won't be 0. Won't be 0 in the interval pi over 4 to 7 pi over 4, because we checked earlier. Was there a question? Yes?
Will the domain of the function and the domain of the derivative of the function, will it always be the same?
Excellent question. No. But they're always very close to each other. The question was, will the domain of this always be the same as the domain of this? And the answer was no, that sometimes the domain of this is different than that, but they are usually very, very close to one another. Sometimes there's points that are okay over here that are not okay over here in the derivative. I can give you a simple example, but I can give you an example of one that doesn't, but let me finish this first. Yes?
So it was positive or negative root 2 over 2, right?
For what?
For sine, for it to be 0.
Uh-huh.
Now, isn't that pi over 4 and 7 pi over 4?
Wait, say again?
Isn't pi over 4 the same as root 2 over 2?
No. Pi over 4 is an angle. Sine of pi over 4 is root 2 over 2.
Okay.
I'm trying to figure out what you're getting at, but I need you to try and...
Well, no, I was thinking about the angle because root 2 over 2 is pi over 4 at the same point. And so if you, I mean, it almost seems like the bracketed limit right there, the pi over 4 and 7 pi over 4 is where it doesn't exist, or no?
Well, we checked in the beginning to say when this was undefined. And it turned out we set like sine of 1/2 t equal to 0, and we went and we looked at it, and we determined that the places where this would not exist or be defined did not happen in here. It didn't happen in this interval. And since to do that one, we had to look at the sine curve. This is the exact same sine curve. We're going to have the same problems that we did here, and we already know that the problems didn't exist in that interval. So you have to go back and look at us when we did that. But don't confuse the angle pi over 4 with what its value is through a trig function. See, you're plugging pi over 4 into sine, it spits out root 2 over 2. Pi over 4 and root 2 over 2 are not the same thing. They're not the same numbers. One's an angle, one's the value of the trig function at that angle. But if I switch it and I say, cosine, you could get a different value. So, all right. Now can we plug in the critical numbers and the endpoints? You ready? This problem is taking a little while, huh? It got kind of interesting pretty fast, didn't it? All right, so I'm going to do f of my 2 critical numbers. I already forgot what they were. Pi over 2, 3 pi over 2, okay. And then the endpoints also, right? Pi over 4 and 7 pi over 4. There we go. We get to plug those into the function. Don't be that person that depends on your calculator to do this, all right? We're going to do this all by hand. Because we're going to get exact answers, that's right. So I need to plug that into the original function, right? You just go into the original function. And I don't think anybody here knows what the value of cotangent of anything is just off the top of their head. But you should know something about the value of sine and cosine. So I'm going to rewrite the original function as cosine of 1/2 t over sine of 1/2 t. That should be no surprise. We did that a little while ago, right? That's the same thing. And now let's try to plug in pi over 2 for t. So we plug it in right here. We get pi over 2 plus cosine of, now be real careful here, 1/2 times pi over 2, pi over 4, over sine of, same thing, right? Pi over 4. What is cosine of pi over 4? So here's pi over 4. What's cosine there? Root 2 over 2. What's sine there? Root 2 over 2. So it's root 2 over 2 over root 2 over 2. That's just 1. So this is pi over 2 plus 1. Whatever that is, right? We might need to get a decimal approximation of that in a little while. But that's the answer. That's what happens when you plug in pi over 2. Are y'all good? Okay. Now we get to plug in 3 pi over 2. We're going to get a different answer. I'm running out of markers. 3 pi over 2. Let me see if I have any more in my bag.
For that, can you just make that 1 2 over 2?
Make what? Yes, you could. Get a common denominator? Absolutely. It wouldn't be wrong, it wouldn't be any more correct, or it's the same thing. Y'all go and try and plug those in. I'm going to go grab a marker.
Yeah, sure.
Hey, Jesse. All right. Sorry about that. So 3 pi over 2 goes in here. Just be careful when you plug in 3 pi over 2 right here, it becomes 3 pi over 4. Right? And that means you're looking here. This is going to change a little bit here. What is cosine of 3 pi over 4? Negative root 2 over 2. And then sine of 3 pi over 4 is positive root 2 over 2. So that ratio will become negative. That makes sense? And then pi over 4. So I'm running out of room here. Pi over 4 plus, all right, uh-oh. What's wrong? Why am I saying uh-oh? Cosine of what? Pi over 8. And why is that an uh-oh? It's not a common angle, is it? That's not a common angle. So I'm not going to be able to get that without a calculator. Right? Unfortunately. So make sure you're in radio mode. Yep. And then you do the same thing with 7 pi over 4. So this one, you're going to get 7 pi over 4 plus cosine of 7 pi over 8 over sine of 7 pi over 8. All right. Well, pardon?
Would that pi over 8 be positive 1 because the same as 1/2 pi over 4?
This right here?
Yeah.
No.
It's not.
Mm-mm. Because it's a different angle. You're at pi over 8 now,
Yeah, it's like 15.
which is right here,
Yeah.
which is 22.5 degrees. But the ratio of cosine over sine there is not, they're not the same. See, when you're at pi over 4, the ratio of the you're right, the ratios are the same, so that's why you get that. So calculator time. I'm not gonna go figure out what it is. Let's take a look at the solution. Let's see what they do here. What number did I tell you this was? 40?
Yes, 47. Kind of hard to tell.
Yeah, I know it's hard. I'm going to erase our stuff. So I have the complete solution manual. And just to give you an idea, that the solution manual is great, but it still leaves a lot to you to have to do, right? I mean, this is it right here. This is their solution. There's the original function. There's the derivative. Okay? When is the derivative 0? Oh, when is that 0, that 0? And they don't even show any more of the work. They just get the answers here. All right?
Well, I'm assuming they're helping the teacher do it.
Well, this is what the student solution manual looks like too. This is just for the even numbers. For the odds, it would look like this also for the student. So at the end of the day, they get this. Pi over 2 and 3 pi over 2. That's what we had, right? And so they plug in the endpoints. At pi over 4, they get about 3.2. At pi over 2, we had pi over 2 plus 1 was the answer. That's approximately 2.57. And then at 3 pi over 2, we had 3 pi over 2 minus 1. That's what we had. And that's about 3.71. And then finally, at the other endpoint, 7 pi over 4, if you plug that in, you get 3.08. So you have an absolute maximum at 3 pi over 2. That's where it happens. And the value is about 3.71. And then the minimum is at pi over 2. Understand? Questions? You have a headache?
Yeah.
We're going to need a calculator to find this thing.
You'll have to use your calculator to find these, yep. And make sure you're in radian mode. When you're doing like, what is sine of pi over 8? If you're in degree mode, you're going to get the wrong answer. All right, I've got about 20 minutes. Yeah, and they're just like that one was kind of interesting. There are several in the homework that are like that too. So make sure you go through the homework and watch my videos on the homework if you run into problems. There's something I wanted to discuss though. It's tied to this section that we have somewhat avoided up to this point, and I thought today would be a good opportunity. These last like 15, 20 minutes. And that is, if we were asked to take the derivative of the absolute value function, what would the derivative be? There's no derivative at 0, right? Because there's a point there, right? An corner, sorry. There's a corner there.
Wouldn't it be,
Well,
it wouldn't be like -1 up until 0, and then +1 after 0?
yes, it would be. That's exactly what the derivative of absolute value of x would be. But hang tight. We're going to get to that in a second. What I'm trying to say is this. If I say, what's derivative of x squared? Here, everyone would say derivative is 2x, right? Now, if I said something like, if I give you sine squared x, then you're going to use a chain rule, right? And you're going to say derivative of this is 2 sine x, then times cosine x, right? You could use chain rule on this. So if I say what's derivative of square root of x, I never gave you a formula, right? I never gave you a formula. And so for sure, if I gave you something like this and asked you for the derivative, you would go, well, I don't know, right? Or would you just say absolute value cosine x? No. It's not. So what we need is a formula for the derivative of the absolute value. And I want to do that. I want to give you a formal formula for the derivative of the absolute value. But to do it, I first need to make sure you understand what the absolute value means. So please note that the absolute value of x is equal to the square root of x squared. That's what it is. In that order, okay? It is not square root of x squared. We do not do it in that order. Okay, so it's this one. Got it? So to take the derivative of an absolute value, you're going to convert it to this, and then you're going to have to use chain rule. You are not going to say that the square root and the squared cancel each other out. You're not going to do that. Right? You're not.
So for that problem earlier, it would be sine squared.
Let's do that one. Yeah, let's do that one. So if I now come in here and I say, all right, everyone, let's start with something a little easier. Here's a function. Absolute value of 3x minus 4. Let's try and find the critical numbers of this. Critical numbers? Well, we'd have to take derivative. Let's take derivative first. Well, to do this derivative properly, I need to convert this over to what it is by definition. So it's the square root of 3x minus 4, that quantity squared, right? That's what I just wrote up on the board. So that's the big thing. If you're going to take anything away from what I just wrote, that's the big thing here.
So the reason it is like that, you square whatever the argument is, so it's no longer negative, and then you take square root.
Then you square root. Yep.
Okay.
So
Yep.
it's jump, squared jump, and then x square root of jump.
Yes.
And that's what will always give you a positive absolute.
That's why it will always give you a positive answer, because you're going to square it first. See, if you try and do the root first, it might be negative, and then you're going to have imaginary numbers problem. All right, so let's try this. The derivative of this would require chain rule on this, right? So what is the derivative of that? What do you see is that we need to do here? 1 over 2. Yes, 1 over 2 root of all this stuff. So what we said here is, okay, we have the square root of something, right? The derivative of the square root of something is 1 over 2 times the square root of that something. Done with the root. Move inside. You've done the root, right? What's derivative of that? 2 comes out, right? Chain rule here. 2. And then 3x minus 4 to the 1 power, or first, right? So we're done with that squared. Times 3.
Why did you put it equals?
I don't know, because I'm tired, I guess. I'm ready. I'm ready to be done. I'm glad y'all caught that.
What do you guys say to watch it?
Thank you. All right, this good? All right, let's just kind of clean it up. Here, here. And so we get, I'll leave the 3 out there. 3x minus 4 over, what, just the square root of 3x minus 4 squared, right? That's what that is. But hey, what is this, the denominator? That's just the absolute value of 3x minus 4, isn't it? Look, right here. It doesn't cancel. It's just going to go like this. That's your derivative. This right here is the original function, isn't it? Because when we converted to here, so now I'm doing is I'm saying, oh wait, hey, that's the original function. And we do not cancel these because they aren't necessarily the same. This could be negative and this one's positive. But what's cool about this is if you plug in a value of x now, it doesn't matter what it is, well, as long as you don't plug in 4/3, then you're going to, you're either going to get here -3 or +3 as your answer. Because whatever this is, right, that could be a positive or a negative. This will be the same exact value, but positive. So this is either a positive something over the positive same thing, which will be a 1, or this could be negative and this could turn positive, and it could be -1. So that would be a -3. But we can't cancel them. That's how you take derivative of a square root. Understand? What did I just say? No. That's how you take derivative of an absolute value. I think that's a sign that I'm towards the end here. How do y'all feel? Y'all want to call it a day? Yeah?
How come we've avoided the topic till now?
I don't know. Because there weren't a lot of problems that were in the exercises where you took derivatives of absolute values. But in this section, there is a problem, number 28, where they ask you to find the critical numbers of this function right here. So you take the derivative, and you get it to here, and then you go through the steps. You want to set this equal to 0, so you just set the top equal to 0. All right, we're gonna call it a day, but let me just make sure you understand. The homework is really like 3 different sections. The first part of it is very visual. The second part of it is find critical numbers. Find critical numbers. Find critical numbers. Don't plug back in, just find critical numbers. Then the last section is here's a function on a closed interval, find the absolute max and mins. So that's the layout of the homework. And I say go after it. Go after the whole thing. If you just if you don't do your homework, there's some problems in there where the algebra gets a little messy, and I'm expecting everyone here could do that. So come in with questions on Tuesday. Have a good Halloween.